Kubernetes, like Docker's containers, do not support data persistence natively. When pods are restarted, recreated, destroyed, the data is gone. So we need the persistence. The problem is, while working with the Docker, we were working on a single node. But we all know that Kubernetes is a self-healing cluster, which means it's a cluster. The cluster is more than one node, at least two nodes, and you can have any number of nodes in your cluster. So the first basic thing is you should have whatever data you are sharing, it should be a remote storage. First thing, it should be shared among all the nodes, on the worker nodes. Because if one pod is restarted on another node, the data should be there, or the volume should be there so that it can read the data from the where the previous pod has left it off. But you have the data store type, which can be NFS. You can use a remote NFS server. You can use a local hard disk. But if you are using the local hard disk on one node, then the point is if that pod restarts on another node, the data is not there. So then we have, just like VMware, we have affinity and anti-affinity rules. So we can define that, okay, whenever you will create this pod, whenever I will delete this pod and recreate it, you will create it on this node only. You cannot create it anywhere else. So for that, then if for some testing environment, we need to create a local storage or we need to use a local storage, we will use the affinity rules. Remote storages can be cloud, anything on AWS and GCP. So we have connectors available. So volume types. We have persistent volumes and we have persistent volume claims. And then we have storage class. What are persistent volumes or PVs? It is the resource which is available to the whole cluster, like CPU and RAM. I mean, the CPU and RAM, they are available to everybody, to every namespace. And just like that, your persistent volumes or your shared storage is available to all the namespaces. I mean, it is a resource attached to your node, not to your namespace. They are defined globally. And they are defined by your cluster administrator, whoever is running that cluster, because the cluster administrator knows the infrastructure. He knows how much NFS he has available. Maybe he just have 25 gigs of NFS or shared storage available. I mean, if it is available on the cloud, you have to pay for it. If you're using the local, you have running a local NFS server, I mean, there are limits on the resources. Maybe he has just 50 gigs available. Maybe he has 5 TB available, but there is always a limit. So he knows how much space he can provide to your Kubernetes cluster. And it is his responsibility that that NFS server is up. It is reachable to the cluster nodes. The NFS should be highly available. It should have redundancy in it. He should take a backup of it and should use RAID or whatever he do. It is his responsibility to make sure that this resource is available. Now, the persistent volume claims, we have two things. Persistent volume is a different thing. It is in control of the Kubernetes administrators and the people, the developer, the staging, and all the teams working in the namespaces. They claim that space. So the claim is defined in the namespace, and persistent volume is defined by the Kubernetes administrator. So if I have 10 gigs available, of course I cannot ask 20 gigs because I have. So under my claim, I will request 10 gigs if only 10 gigs is available. So that's how you can control your resources wastage. Let's the storage class. PV and PVs are automatically created by using storage class, and a lot of work is reduced. I mean, the Google is providing their own storage class, AWS is providing their own storage class, and let's see, what time is it? We still have time to go for the lab. So that's it for the theory. We have persistent volumes and we have persistent volume claims. Any confusion in this so that we can go to the lab? There can be a lot of parameters. I am saying, so this is persistent volume. It's not a claim, it's a persistent volume. Data is, I am saying it a PV local because it's persistent volume local. Type is local, and I am using the local storage. The class name is local storage, and the reclaim policy is recycle. I mean, you can do recycle, you can do retain, you can do delete. But if you do retain, whenever you want to release it, when your claim is released, I mean, the pod will release it, but it will be the responsibility of Kubernetes administrator to delete it manually, because you have set the policy to retain, and maybe someone has accidentally deleted it and they want to get it back. So the policy should be retain. I mean, you can do recycle, you can do delete, it depends on whatever you want. So you have many options. The capacity is, you can define 1G, you can define 10G, 100G, it depends on your backend infrastructure. Okay, we have access modes. Let's go back to the presentation. Access modes. Read write once. The volume can be mounted as read write once by a single node. Read write once access module still can allow multiple pods to access the volume when the pods are running on the same node. So one node can read and write, and all the nodes can read from it. Read only many. So you can define, okay, this volume is writable by a particular node, and all other nodes will read data from it. Maybe you are running some what should we call it, the reporting thing. So the reports, what they do is they will just pull the data, they don't write the data. So you can say that, okay, you have so many replicas, so these will be reading from this and I will be writing to it. Read write many, so you have this so many parts of the same application and they are serving the customers. So every part is listening to the serving the request, and they are reading and writing on the same storage on any number of nodes. So these are the concepts of read write once or read write many. And if you are defining the driver NFS, so the NFS has its own parameter. So I was showing local has its own parameter. If you are talking about GCP, it will have their own parameters. And okay, I was saying you just first create PV, and the PV name was PV NFS, and the storage class name was just NFS. Here again, I will use the storage class name NFS because I am defining here storage class will be NFS, and I can name it PV NFS. So when the storage class will be the same, the PVC will be bound to that PV and the mapping will happen. If the storage is 1G here, you cannot toss 2G here, otherwise the mapping will not be done.
So it has to be the same.
It can be less, but it cannot be more.
Okay.
So again, I took a screenshot of that configuration file. I took it because it will be a reference for anyone that it's a persistent volume. Okay, it's a persistent volume. Type is local. Storage can be 10 gigs or whatever you want. The only important thing I want to show you is you can mount a local path /data. So on your that host or on which you are working on, it should have a data directory available. And this is a node affinity rule. What's a node affinity rule? Okay, required. What is required? Node selector terms. What terms are we using for the affinity? Match expressions. So the term is I will match expression. What expression? I will say Kubernetes IO hostname, and the value can be worker node 1. So whenever the scheduler gets the request, it will see what is written in the etcd. If there are affinity rules, so it will search for worker node 1, and it will create this pod on that worker node only. So it will get the host name. It has the host name of everybody because it knows everything. The scheduler has the complete visibility. So I am telling you can use the operating system, you can use the IP address, I mean, whatever you want. So the affinity should be there if you are working with the local storage. Otherwise, the local storage will not be available on all other parts. So Let's go to the terminal. Okay, no, this is not the terminal. This is the terminal. So I have cd 6. It is very simple. kubectl apply minus f. First, we have to create PV. If PV is not there, how you can use the claim? So if everything is good, should work. If you say kubectl get PV, okay. I have not deleted them. So first I have to delete them. Okay, so let's do the lab tomorrow because now I have to delete this. So I have to delete first I have to delete first PVC local because it is already bound PVC. So that's deleted. Then I can say delete PV. Then I can say PVC NFS. And then I can say PV NFS. So I can say kubectl get PV and PVC no resource found. If I say kubectl apply minus f PV dash local, it is there. If I go get PV, so PV is saying, okay, the name is PV local, capacity is 1 gig, access mode I have defined, reclaim policy I have defined, status it is available. So if I am working on somewhere and I need to have a space, I can see that this is available and I can create, okay. And if I had hit PV again, the status is bond is created, and the PV is claimed by the PVC. So we saw that whenever we delete our deployment, all the pods are gone, and so is the data. So we have to create the persistence. For that, we discuss the PV and PVC, and we know now how they are bound and how the PV are claimed by the PVC. So how now we have our PVC and PV bound together, so we have space available. Let's see how to use them in our deployment. So this is MySQL deployment, and I want my MySQL data to be consistent, and I don't want it to be gone when my pods are destroyed. So whenever I am creating our deployment for MySQL, under the specs, I will use volumes. I am calling volume the name data, and I am calling the persistent volume claim, and the claim is PVC local. Because I have created a PVC local, I have created it with this name. Let me show you. So this is the name PVC local. So I am calling this claim here, and under the volume mounts, while creating a container, these are in specs, and this is in my containers. MySQL, the image name this is MariaDB, whatever version you want to use, and the volume mounts are on the mount path var lib MySQL. So this PVC we created, and we are now using it here so that our data is mounted, and we have the data persistence available. So PVC and PVNFS. So just like when we were defining PV local, we can define the name PVNFS, and we will just give the IP address and the path of NFS server. And the claim mechanism in the file will be the same. It will be just like we can change PV local to PVC local to PVC NFS, whatever we have defined here, PVC NFS, yes, PVC NFS. So we will define it here, and everything will start be going to the NFS server.